So, good afternoon, everyone. I'm audible. Okay, so hello, everyone. Dear authors and invited guests, welcome to Technical Session 12B. I am Raj Nandini Patil, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and JR Scholastic, it is my great pleasure to welcome you to the 10th International Conference on Smart Trends in Computing and Communication, Pune, India. The 10th edition of the conference is being organized in hybrid mode. The virtual event is being held through Zoom from 19 to 21st of January 2026. I hope you will enjoy the knowledgeable and interactive session through the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentation and 2 minutes for question and answer. On 9 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remark. If you have any query or update, then you can write it to me in chat box. Just before we start the session, I would like to introduce all for the chair of this session. And that's Dr. Nisha Abhijit Auti. So, Dr. Nisha Abhijit Auti is an associate professor in the Department of Computer Science and Engineering at Bharatiya Vidyapit College of Engineering, Pune, India. With 14 years of experience, her research interests include artificial intelligence, machine learning, data science, and cybersecurity, and she is actively engaged in teaching and research in this area. Welcome to the session, ma'am. So, now let's start with our first presentation. For this, I would like to call Shiv Kumar Patel for the paper title A Hybrid Multi-Layered AI Surveillance System for Real-Time Weapon and Behavioral Threat Detection. I kindly request the presenter to start with the presentation.
Hello, am I audible?
Yes, you are audible.
Is the screen visible?
Yes, it's visible.
Good afternoon, everyone. My name is Supatal, and today I will be walking you through our research presentation. Our study is titled "The Hybrid Multi-Layered AI Surveillance System for Real-Time Weapon and Behavioral Threat Detection." This project was a collaborative effort developed at the Institute of Advanced Technology and Research, and our primary focus was to move beyond the simple object detection towards a more complex security solution. So this is the content which will be presented by us in this presentation. To start with, we must acknowledge the growing global demand for high energy, high efficiency security. While AI has made great strides, traditional monitoring still suffers from significant limitations, specifically in detecting weapons and recognizing abnormal human behavior in real time. Our research objective were to bridge this gap by creating a general real-time security system. We aim to develop a solution that reduces false positive in dynamic settings, like tracking subject based on the proximity and context. Now, while by looking at previous work, we've seen a clear evolution in object detection model. Earlier studies utilized the YOLO version 3 and 4, and they were effective for detecting firearms in open spaces, and more recent studies have utilized version 5 and 7, and they have enhanced community support for better detection rate. Furthermore, some systems also have integrated media pipe to track head movement. However, our work stand out by integrating this advanced architecture with a YOLO version into a unified multi-layer architecture that handle both object and behavioral detection simultaneously. The core of our lies in addressing three critical problems. Firstly, traditional surveillance is inefficient and lack real-time recognition capabilities. Secondly, false positive rate in congested environment is traditionally quite high. And finally, current solutions lack of spatial context. They don't account for how close the subject is to the camera. Going to the methodology. This flowchart here illustrates the operational logic of our hybrid surveillance system. The process began with system initialization. During this phase, we load our retrained deep learning model, establish a necessary connection with APIs in the user interface. Critical component here is interactive setup. Operator defines a restricted zone directly onto the live feed. This zone purposes primarily serve as a spatial constraint for our rule-based behavioral triggers. Once the frame is validated, the system enters into the real-time processing loops. And for every single person identified, the system branches into parallel analysis, simultaneously check for variety of threats like zone breaches and more specifically explicitly presence of weapons. Based on this finding, the system assigns an alert level to each individual. Once all personnel in the frame are concealed, the system draws a zone onto the frame and displays it to the operator. So the operator can easily be able to see what the system has detected, like emotions. The system is currently capable of detecting emotion and the threat, threat like weapons. For distance estimation, we have used the multitask scale convolutional network and pinhole camera model to establish subject distance in centimeter. For subject within 200 centimeter, we analyze the facial landmark and emotion using media pipe and to identify the suspicious intents. And for those who are further away more than 200 centimeters, we use the convolutional autoencoder to detect the motion anomalies like fall based on their reconstruction error. And finally, YOLO version 8 assigns persistent ID to monitor rules like zone violations. And it also signals the fed into unified, it's sig- also the signal are fed into a unified assessment engine, which prioritize threats from level 0 to 3. And when a weapon detection, where if a weapon is detected, it overrides all the alerts. And now my teammate will be continuing with the experimental research and discussion.
Hello, am I audible?
Yes, you're audible.
Okay, so I would like to walk you through a little bit of architecture and justification of our methodology. So, first of all, as my friend mentioned that we are using the MTCNN for detecting the phase, and we have selected the distance of 200 centimeter only because it was working the best for us. And based on our hardware and other requirements, these are the best specs that are working for us. But we would say that the further models of YOLO could be used, but uh, they do not excel in the speed like YOLO V8. Uh, so we have tried to uh, come to a middle ground where speed and precision both are met nicely. Uh, in this project, uh, we have a three-level uh, alert detection system. First of all, okay. First of all, whenever a person is staying still at a position, the person will mark as loitering. That is, person is not changing his position and just staying there without any purpose. Level 2 alert is when a person enters a marked area which is restricted for a person. So, as you can see in the images, whenever a person enters the restricted area, the person is marked with alert level 2. If a person is carrying weapon, then the person will mark as level 3 alerted and alarm message will be passed. Okay, so I would like to conclude by saying that this is a very smart and efficient way of analyzing the security in public places. The traditional system are very uh, pesky and they require manual work. In the modern era, uh, with the upcoming technologies like AI and generative AI, it is more efficient way to use deep learning architectures and computer vision technologies to do the task automated. Thank you.
So thank you. Ma'am, you can proceed with your questions.
Sure. What are the limitations of the existing system that you have studied?
So the limitations are that first of all we do not have a good hardware. That is, we are running all the models concurrently, like for uh, position detection, for weapon detection. These are all fine-tuned models and they are all running concurrently. So we require a good hardware. Plus, we also require a good camera quality also. We have also found out that when we provide a blurred image or the quality of image is low, that is frames, the performance is not so good as we might expect.
And what type of weapons you have considered in your research or your work?
Uh, we have considered weapons like knives, small handguns, and rifles. Uh, the model is currently not able to detect other type of weapons like wooden stick or some small small sharp objects. It is not able to detect such things.
What data set you have used?
Uh, I have actually used a combined dataset from Kaggle and RoboGlobe.
And what are the database features?
Sorry.
What are the features of your data set?
Uh, Dataset contains pictures of weapons solo. I mean only weapons, and it's on my. So the dataset contains of first of all weapons, people carrying weapon, and uh,
And what is the accuracy of your model?
uh, accuracy. Actually, accuracy is not so good, but we have measured the model with other metrics like confusion metrics, precision, and recall. So precision is
What
0.8422. Recall is
what
sorry.
factors are affecting your accuracy?
Uh, First of all, we do not have a proper data set. Like we have to use generated images and all that. So we do not have a proper ready-made data set, and we have used currently the uh, training data set only, but the model does not perform well enough.
Okay.
Okay, so
Anything
thank
else?
you. So let's proceed with our next presentation. So for the next presentation, I would like to call Durga Prasad for the paper title A Robust Hybrid CNN 2D Ensemble Model for Ransomware Detection from System Usage Data. I kindly request the presenter to start with the presentation.
Hello, ma'am. I'm audible?
Yes, you audible.
Yeah, ma'am. I'm sharing the screen. My screen is visible, ma'am?
Yes, it's visible.
Yeah, ma'am. Hello, first of all, good afternoon to everyone. Yeah, myself, Durga Prasad, from the Department of Computer Science Engineering, and from the Godavari Global University, which is in Rajahmundry. Today, I'm here to present our paper title, A Robust Hybrid CNN 2D Ensemble Model for Ransomware Detection from the Disk Usage Data, means system usage data. Uh, the next slide. It is visible, ma'am?
Yes, it's visible.
Yeah. Coming to the abstract, ransomware detection offense introduces heavy monitoring overhead and risks data contamination. In our work, instead of monitoring inside the virtual machine, we collect the CPU and disk I/O events from the host system. Using machine learning models, especially random forest and ensemble techniques, our system detects 22 ransomware variants along with the normal user workloads. This approach minimizes overhead, avoids ransomware interference, and adapts well to the different workloads. It is about the abstract. And coming to the introduction, yeah, ransomware is a rapidly growing cyber threat that encrypts or locks user files, making system unusable until a ransomware is paid. Like it, global losses are expected to exceed the $265 billion by 2031, highlighting the seriousness of the problem. Traditional signature-based detection fail against the modern polymorphic and metamorphic ransomware. Behavior-based techniques are also bypassed by the advanced ransomware that partially encrypts the file. Therefore, machine learning and based detection using the hardware and system behavior provides a more adaptive and reliable solution. Coming to the our system architecture, initially user data resides in the cloud environment. When when a ransomware attack occurs, these events are collected as a dataset containing both normal and malicious behavior. The data is then pre-processed to remove the noise and followed by the feature extraction to the identify ransomware patterns. The extracted features are fed into the ransom net model, which includes the machine learning and deep learning classifiers. Finally, the system performs real-time attack detection, evaluation, performance, and produces the ransomware prediction. Next thing, literature survey. Early ransomware detection techniques mainly relied on a signature-based kind of model methods, which are ineffective against the polymorphic and metamorphic ransomware types. To overcome this, researchers proposed behavior-based detection and monitoring runtime activities such as file encryption and system calls. Dynamic analysis improved detection by focusing on action rather than the static code. However, the modern ransomware families like Lockbit uses partial encryption, allow them to avoid these methods. Recent studies emphasizes machine learning based detection using CPU events, disk I/O, and hardware performance counters such as Ranstock and RW got like something Shield FS and enable advanced techniques like deep learning and entropy analysis improved accuracy. Still, challenges such as false positives, noise, scalability, and data contamination remain motivating our approach. Coming to the existing system, existing ransomware detection systems monitor processes directly inside the target machine. This leads to high resource usage, possible system slowdowns, like vulnerable to the system ransomware interference. These systems is also struggle to adapt the different user workloads, limiting real-world effectiveness. The disadvantages are the causing the potential slowdowns. It increases the overhead. New ransomware can disrupt the monitoring and compromising the data integrity. Our proposed system collects the CPU and disk I/O events from the host machine instead of the target virtual machine. This significantly reduces the monitoring overhead and prevents the data contamination by ransomware. The system adapts well to varying workloads and uses machine learning to provide a fast and accurate detection. Random forest plays a key role are achieving reliable performance. Our methodology, we evaluated several machine learning and deep learning models. First, coming with random forest. Random forest analyzes the CPU and disk I/O events and reduces the overfitting through the ensemble learning. Where coming to the CNN 2D learns spatial patterns from the system event data, automatically extract the features. And coming to the voting ensemble model, it combines the random forest and CNN 2D predictions that improves the accuracy. LSTM also captures the temporal patterns, making it effective for involving ransomware behavior. There are few algorithms are there. Also, deep neural network. DNN learns complex nonlinear relationships in the system level data. Coming to the XGBoost provides the fast and accurate detection even in the noisy conditions also. Decision tree offers the interpretability, uh, easier to interpret and analyze it. KNN and SVM handles the high dimensional data. This is the results we have. First, we have directed to the dashboard and entering the inputs, which is disk IO events, required events. Data will be entered, and if there is any ransomware attack is there, it shows the result as ransomware. Otherwise, it's benzene. Coming to the conclusion. In conclusion, our project presents an efficient ransomware detection system with minimal performance and impact. Random Forest and XGBoost achieved strong results. The voting ensemble classifier achieved 99% detection accuracy, proving our robustness. Integration with Flask and SQLite ensures the security and usability and real-world practicality. Next, the future scope. In the future, the system can be extended to detect the new ransom variants. Maybe it can be advanced variants and tested in real-world environments. Additional machine learning and deep learning models can explore to further improve accuracy. That's it, ma'am. Thank you for your time. Thank you.
Okay, thank you, Durga. Ma'am, you can proceed with the questions.
Yes. Which data set you have used for your studies?
Ma'am? Hello.
Which data set you have used for your studies?
Ma'am, we used the Kaggle disk data IO events dataset from the Kaggle website.
Okay.
It is a predefined dataset for the practice we used.
How many features are there into the data set?
Features means, ma'am, there are several categories are there.
Huh? So what feature engineering you have done onto your data set so that it will be easier? I mean, it will be ready for applying the machine learning model on that.
Yeah, ma'am. Like features means like you asked previously. Features means CPU performance counters like disk IO features, process level behavior like workload characteristics and label information like beginning and ransomware activities like workload behavior. There are several kind of features are there.
And how the random forest is most suitable to your problem statement?
Hello, ma'am.
Hello.
Hello.
Have you evaluated your model to be selected for the random forest?
Yeah, random forest is a robust learning model. Coming it handles the high dimensional CPU like IO features effectively, and most importantly, the main kind of the feature of the random forest is it reduces the overfitting by combining the multiple decision trees. Also works well with the nonlinear and complex ransomware patterns. So moreover, it is the robust to the noisy and feature variations. It also provides the high accuracy with a low computational overhead. Man. It's about the random forest.
Okay, fine. Done from my
Okay,
side.
thank you, Durga.
Yeah, ma'am. Thank you. Thank you for
So,
opportunity.
so for the next presentation, I would like to call Chandresh for the paper title AgriConnect, a smart platform for agriculture trading and predictive analysis. I kindly request the presenter to start with the presentation.
So can I audible, ma'am?
Yes, you audible.
My screen is displayed.
No, it's not visible.
Not visible. So thank you. I will give the Yeah. Now, so, so first of all, good morning, ma'am, and my paper ID is 2202, and my paper title is AgriConnect, a small platform for agriculture trading and predictive analysis. So here my name is Chandresh Lakani, and other author is Smith Mania and Nisha Sheikh ma'am. And now move forward to the my presentation of AgriConnect. So this is the outline of my presentation. Basically, introduction, motivation, objective, literature survey, existing approaches and limitations, and also methodology and results and competitive analysis and future scope and conclusion. And last is a reference. So now move forward with the introduction. So basically, agriculture plays the virtual role in economics development and modern agriculture is a dynamic for the climate changing and market pricing. So basically, most of the problem is now farming is like you can go on a sale or sell in a market. At that time, you can see the most of time intermediate are facing in this market, and also you can see the not proper crop price you can get in a market, and also limitation is like you cannot know very well amount of fertilizer you can use in this way, and you can get a more amount of revenue in products. So my goal is basically AgriConnect aims to develop a smart platform like you can sell your product here on our platform also, and you can get some idea like you can which types of fertilizer you can use and get more amount of predictive means more amount of revenue, and also you can see the digitalized real time pricing suggestions, and also you can see the weather forecasting also, and you can see inside this yield wise prediction you can see inside our platform. So now move on the motivation. So basically, our motivation is you can see the lack of transparency. You can see inside the trading means sale of the product. So intermediate can reduce your price in the market, and also you can see the not whether completely baseline on. So you can see the weather anytime it can change. So so you can see the lack of transparency inside it also, and farmer depends on a heavily intermediates. Yes, you can see inside market you can sell your product at the time intermediate also everywhere, and it can get a low amount of price your product and sell in a high amount of, so you cannot get proper pricing of your product, and it will get your cost. So basically, the limitation is like reliable price on a forecasting with weather and rainfall prediction and fertilizer recommendation. So now move forward with the introduction. So basically, and ARZU and Priya ETL flows on, and now our paper presentation like AgriConnect, and now focus is on area. You can see Patil ETL. So inside it is a crop price prediction. Use the random forest and XGBoost. So basically inside this you can see your key contribution like improve accuracy of agriculture price and forecasting. So basically you can see the limitation is like a regional data. Can see the very sorry ma'am now. Why? I don't. Oh, sorry. So now limitation is, you can see the limitation, regional data is not acquiring. So now on ARXU, so inside commodity price forecasting, so inside use LSTM model and high predictive accuracy. It will get high predictive accuracy, but you can see the high comprehensive cost because of, you can see the LSTM use. So it will get data on vectorization form, and high amount of data you can get, and you can train your model, and computational power also acquired. So it will take high computational cost. So it will take a high amount of costing, so it will not very well work. And now PITL, so inside fertilizers recommendation, can use decision tree and data driven from the fertilizer suggestion. So limitation is weather impact on uh, fertilizers, means what types of weather and what types of illness in a product. So you can see in this, and after you can suggest your fertilizer. So it will lack of limitation in this paper. And also loss on, so inside price forecasting use ARIMA and ANN. So it will give better amount of accuracy, and also predictive amount very high. But limitation is not advised market integration. So you can see the market live price is what, it is not integrated, so it will not very well work. But now our paper like AgriConnect, so inside you can see the integrated agri platform also. It is web and ML, both are used. And key point is unfilled unfilled market with prediction. So basically our platform is working on a buyer side also, seller side also, and also it will give the suggestion for the farmer, what types of farming product you can add in your land. And also you can how amount of production you can product in your land. And also you can see the what is a price, real time price of your product. And also you can see the what types of fertilizer you can use for this product. So now move on the existing approaches and limitation. So existing approaches like five existing approaches like trading agriculture market, standalone price prediction system, fertilizer recommendation tool, weather forecasting system, and digital marketplace. So trading traditional agriculture market, inside you can see the farmer sell all products in this platform. So it will lack of price transparency. It will you can show in a like an intermediate platform. So it will not give proper amount of productive idea. Basically, not get a proper
Sorry for the
amount of pricing.
interruption, but you only have 1 minute to complete the presentation.
Okay, ma'am. So now move on the another part of my presentation, like methodology. First of all, I have get a data, all amount of data in a data.gov through, and all is a real time data, and get through the API. And now convert into CSV. And I have used the all types of modeling like random forest, decision making tree, and also CNN, and also LSTM also. And also I have used vector support machine, and also KNN. All types of model I have used, and another method because of getting high accuracy for the my model. So now methodology is like first of all getting data, and now clean this data, and after you can I have reduce the whole data amount, means nullable value, and fit on into the model, and getting RMS, MAE, and R2 score for this. And now after I have integrate in a system. So in a system, I have used a Python Flask, and in a backend, I have used PHP and MySQL also, and creating the RESTful API for this. And this is my result of my models. Basically, my accuracy and RMSE and MAE and R square I will display you. And overall result, I predictive accuracy across the all agriculture models and reliable on a data-driven decision supports for the farmer and efficient integrate in a analysis. So now competitive analysis, you can see all platform. I will give the competitive analysis for this. And now future scope. Basically, if in a future scope, I have scalable this platform and also develop on my cloud platform and my not mine but AWS or GCP. I have used cloud platform and my display my product into the market. So my goal is like it will display on a market. So now conclusion. Basically, our platform is how to work. I will give more amount of idea of my product, but I have also give the conclusion like AgriConnect provides integrated smart platform, combines agriculture and trading with the machine learning based predictive analysis and support decision making for the how what is a weather forecasting, what is a price, and what is a fertilizer you can use in your product, and also the yield wise estimates give. So now thank you for my side. So any types of question you can ask me.
Thank you. Ma'am, you can proceed with the questions.
Yeah. Uh, just tell me what makes your predictive model unique?
Okay, ma'am. So
How
basically
does it
I have
make your predictive model unique to the style?
yes, ma'am. So I will
Yeah.
say you because of
Okay.
it will stand alone in the market because of I have data take from the real time database means data.gov. It is like it is provider digitalized means every years of data it will put in a data.gov and I will get through this, and also my model accuracy is max to max 85 above all models. So basically it will work very well. So I it will provide a more amount of accurate suggestion of your price or fertilizer or yield based prediction or any else other else.
And what is the main novelty of your work compared to the existing studies?
Yes, other I will give you the literature analysis. Inside you can see the all my my competitor are display your product, and also he can provide a more amount of ideas and accuracy, but not integrated something not integrated in your system, so it will not efficient. But my system inside I have integrate all of things. That's like problem into in the life of a farmer, so it will very nice platform. Hello.
What will be
Hello.
your potential social? Hello, am I audible?
Yes, ma'am.
Hello. Yeah. What are the practical applications and potential societal impact of your work?
So basically, my father and my grandparents are working on this farming stream. So basically, I will see all the problems in a real time. So I will catch this problem and solve this problem. So in this solution, add to in this my solution. So it will create one platform like this. So I will use this platform for market or every farmer.
Okay, done from my.
Okay, ma'am. Can you please answer your presentation?
Hello.
Yes.
Hello.
Yeah, you're audible.
Yes. So now,
Yes, it's done. So for the next presentation, I would like to call Rishi for the paper title Designing Wavelet Guided Denoising of Low Dose CT Scan Using a Frequency Domain Cross Attention Unit Architecture. I kindly request the presenter to start with the presentation.
Good afternoon, everybody. Am I audible?
Yes, you're audible.
Yeah. I am Rishi Anirudh from Amrita Vishwa Vidyapeetham, Bengaluru. So, my research work, wavelet guided denoising of low dose CT scan using a frequency domain across attention GAN. Uh, yeah. So, basically, the introduction the CT scan imaging is widely used for uh, diagnostic purposes. Low-dose CT scan reduces radiation, but it reduces signal noises. Low-dose CT scans affects visualization of fine structures and accuracies also. As like we know, the traditional filtering over smoothes the images and remove the important details, which might lead to the misconception of the doctors and may lead to the other works also. And we in the deep learning improves denoising but may blur texture or create artifacts. We need a model that removes noise without losing any autonomical details. So the problem definition goes like low dose CT scan images are captured using less radiation, but this causes strong noise and streak artifacts that damage important fine details like edges and boundaries. Most existing denoising methods either remove the noise but also blur the important structures or preserve the details while leaving noise behind. The goal of this problem is to design a model that combines wavelet transform and GANs to efficiently remove noise from LCD images while preserving texture and structure details so that restored images look like as close to possible to normal dose CT scan image as the same quality image. As from my literature survey, as most of the limitations of all these papers are may struggle to preserve structure or optimization of the CT medical imaging noise, and also not specifically designed for LDCT denoising, and effectiveness under complex noise patterns. And in some of the papers, like most of the methods does not remove the noise, but also they remove the crucial important existing features of the CT scans. So the problem it solves is reduces excessive noise, prevents in low dose CT images, preserves fine automatical detail that are often lost in traditional denoising, prevents oversmoothing caused by casual filtering techniques, produces image closer to quality to normal dose CT scans. Uh, yeah, and the data set we have used, the data set consists of pairs of low dose CT scan and also the normal dose CT scans. This this basically in the format of DICOM format. Basically, this is a format used for the medical imaging, and the source we have taken the data set is from Mayo Clinic low dose CT scan challenge data set, which is used as a benchmark which is widely used as a benchmark to for the low dose CT scan challenges. And the pre-processing steps are like sorting the CT scan slices into the correct order and converting the pixel values into house filled units. Basically, the house fill units are a standard numerical scale used in CT scans to represent tissues densities, and also stacking the slices into 3D volumes. Each low dose CT scan slice is decomposed into 2D discrete wavelet transformer for the frequency domain analysis. Why we have used wavelets? Wavelet transformation decomposes image into frequency subbands like LL is basically low frequency structure, and LH, HL, HH high frequency textures. The noise appears mostly in the high frequency bands, which is LH, HL, and HH. Structural detail are preserved in the LL bands. The main important features are preserved in the LL. perfect for frequency-aware denoising. And the proposed solution is we have used wavelet decomposition to separate the structure and noise. So, and using the cross attention to guide high frequency refined using low LL bands. GAN ensure visualizing a visually realistic normal dose CT scans quality output. And the hybrid loss ensure both the perceptual and pixel accuracy. The methodology overview is like pre-process the low-dose CT scan and also the normal CT scan slices, convert them into house field units and normal and extract the patches. Patches is nothing but like the low dose and the high dose. That apply 2D discrete wavelet transformation. Basically, in the LL, the structure extraction and the LH, HL, HH refines the cross attention layers. Combining ensures the coefficiency applied in the we have applied it in the inverse discrete wavelet transformation to reconstructed the denoised CT scan. In this you can see the low frequency, the LL, LH, and HL, HH, what and which carries what type of information in the slices. Basically, it learns how high frequency texture should align with the low frequency texture, and also highlights the real edges and suppresses the noises. Wavelet GAN architecture. The generator, basically in the generator uses wavelet LL, HL, uh, LL, HL, and HS decomposes. LL provides structure, and the high frequency bands refines via across attention, and the decoders plus inverse discrete wavelet transformation cleans the CT images, and the discriminator uses a patch gain classifier which judges small images patches instead of the whole image. The help of the model focus on local texture and encouraging the sharp edges and reduces blur in the reconstructed CT images. The loss function. The loss function guides the training. Adverseful loss makes the generated image look realistic like a normal dose CT scan, while L1 loss ensures the structure similarity with the ground truth. The final loss is a weighted combination of the both balancing realism and accuracy. As the results, you can see the low dose CT scan, and after the denoising the low dose CT scan is uh, is matching with the normal dose CT scan. So which helps the predictors to work on their thing efficiently. And as coming to the results, as our peak signal to noise ratio improves from 33 dB noise from 35.3 dB by our proposed model. And also SSIM, structural similarity index matrix, is also improved from 0.933 noise to 0.966 by our proposed model. And the outcomes wavelet filters and LNM, the non-local means on the both the matrices. And the training matrix, the smooth decrease in training and visualization loss by the GAN training. And validation in the peak signal to noise ratio steadily increase, covering nearly 36 dB noise. And in the comparative analysis, the proposed model preserves edges and anormatical texture better, produces normal dosed CT scan like quality without over smoothing. So, and also the strong balance of noise suppression versus the detail recursion. Overall outcome is like the wavelet GAN architecture has highest PSNR and SSIM and best visual quality among the compared models. And the conclusion, proposed wavelet GAN produces superior LDCT, like low dose CT scan denoising across the attention, enabling the structure guided high frequency refinement. achieves high peak signal to normal ratio, and also the structural similarity index matrix and excellent perceptual quality. So our future scope is to extend this to the 3D volumetric CT scans and integrate the transformations or diffusion models also. In the real-time deployment, it in the CT scanners, and we may go for the clinical validation in with the help of the radiologist and domain applicable for multiple hospital data sets. Thank you.
Okay, thank you, Rishi. Ma'am, you can proceed with your questions.
Yeah. From where do you get your data set?
So basically, ma'am, it is from the DICOM medical format in the Mayo Clinic dataset.
What is the size of the data set?
Sorry, ma'am.
What is the size of the data set?
So basically, it consists of 70 low dose CT scan and normal CT scans, which are in that DICOM format, and also these are all in the paired slices. Hello.
What are the issues you have faced in deploying this model?
So basically, the issues is nothing is like the after the denoising the image, the mostly the exact structure and the edges were missing in the sometimes. But after using the R model, the edges were also after denoising the normal dosed CT scan from the low dose CT scan, the edges were similarly. The edges were not that much similar, but it is accurately 78% similar to the low dose CT scan.
What is the main novelty in your work?
So, ma'am, basically it combines wavelet decomposition with a GAN. So the model learns where noise exists and where important detail exists, allowing it to remove the noise while keeping the edges, texture, and the medical structure clear. Like making the low dose CT scan image look closely to the normal dose CT images.
Okay, done from my side.
Okay.
Thank you.
Thank you, Rishi. Can you please unshare your presentation?
Yeah.
So for the next presentation, I like to call Lakshmi for the paper titled Digital Health for Maternal Mental Health in LMICs, Systematic Insights on M Health, Telemedicine and Equity. I kindly request the presenter to start with the presentation. Yeah, you can proceed, ma'am.
Good afternoon, all. I'm Lakshmi Sunita, follow from Umbra School of Business. Today, I will present systematic review, digital health for maternal mental health in LMICs, systematic insights in health, telemedicine, and equity. And this is the presentation outline. That is an abstract, introduction, methodology, result and discussion, implication, conclusion, and future scope, limitation of the study, and references. And this is the abstract. Digital intervention reduce postpartum depression symptoms, improve the EPDS scores. And most of them come from high-income countries, limited LMIC studies, mobile phone, SMS supports, and telemedicine counseling, and most scalable. Key challenges: it consists of low internet access, limited smartphones, and low digital literacy, and better outcomes when programs culturally adapted in the local languages, and community health worker involvement, and family support in the improve engagements and scale up needs integration with mental health services, more LMICs. And next comes to introduction part. Postpartum depression is the major global health challenge with higher prevalence in LMICs, that is 15 to 28% in high-income countries, contribute to maternal mortality, infant developmental delays, and intergenerational um, intergenerational poverty. And in traditional, many LMICs are constrained. One mental health worker per 100,000 population, stigma, high cost, and poor accessibility. 80% mobile penetration are improving internet access in LMICs. And the successful implications requires infrastructure readiness, cultural adaptation, and health system integration. And we structured some questions, research questions, that is, which digital delivery modalities have been used, what evidence exists for effectiveness and scalability? How do cultural adaptation strategies and community integrations affect success? What implementation barriers and facilitators? Policy framework support scale up. And this is the methodology portion, and we follow the Prisma. And we targeted Scopus English peer-reviewed articles from 2020 to 24 using digital health and postpartum depression. And after screening, 20 articles or meta-inclusions, RCTs, pilots, and implementation studies. And from each studies, we extracted modality, outcomes, adherence, equity notes, and implementation details, and then synthesized the results thematically. And this the table represents the table summarized represents studies that is RCT in Turkey combined online counseling. It gives global depression scales. And in web of psychoeducation in British Columbia, based on CBT for modules, it gives us greater experience and lower anxiety within 4 weeks. And in Nepal and Chile, WhatsApp and community health work-based counseling program engaged husbands to support maternal fertility. It gives strong family engagement. And this is the illustrate is the mixer of RCT, pilot, and observational design in the evidence base. And almost all modalities are merged, and smartphone apps, web platforms, telehealth, CBT-based psychoeducation and self-training, reminders, peer support, bilingual, simple language, culturally adaptive. Hybrid models combine in-person, virtual, reported higher acceptance. And many users use user-centered design, improve usability, and the effectiveness and adherence is to moderate to large reduction in postpartum depression that is reported in RCTs, and EPDs and anxiety scores, that is the web-based app-based program, and mother-infant bonding, that is some interventions also include, and generally reduce PPD symptoms, that is within some digital programs. Engagement often declines over time, and high during programs, that is short-term adherence. Hybrid and flexible model shows good user acceptance, and few studies access long-term outcomes and sustained use. It is overall digital programs use reduce postpartum depression, but sustainability and real world affect more robust trials. And many researchers came from North America, Europe, and Australia. Very few studies in under-deserved or LMIC settings that are such as Nepal, Chile, etc. And none or very few in lowest income regions such as Sub-Saharan Africa and rural Asia. And the equity concerns such as non-English speakers, indigenous, and migrant mothers underrepresented. And The facilities included convenience and flexibility, peer, partner, and family support, user-centered, co-designed tools, and the barriers are limited internet access, law, digital literacy, privacy and data security concerns, socio-cultural barriers such as stigma, child burden, work time conflicts, and financial constraints are weak reimbursement for telehealth, and the implication refers stronger infrastructure, digital skill training, privacy safeguards, and integration into mainstream healthcare funding and delivery. And this is the thematic map, and it is structured into a four clusters. That is early web-based and formatic research. That is e-health, telemedicine, and women health. That is in green cluster. And growth of mobile screening and self-management tools. That is in mHealth, smartphone, apps. That is also an yellow cluster. And CBT-based psychoeducation anxiety shows evidence-based therapies in digital forms. That is in red cluster. And purple cluster, penetration, prenatal care, prevention, maternal morality. It shows links to both the maternal health goals and the bridging concept, social support, mental health shows indicate expansion of virtual peer support and daily health. And overall, first we study mobile first and solution and support programs embedded in routine perinatal care. And this is the implication part, and we arranged it into three parts. Research and design insights. Digital postpartum depression research, mHealth adoption with maternal health outcomes, and the future models can access usability, language flow, and role models with behavioral change construct, and recommended a corpus adaptation model, strengthen privacy by design, and research priorities are large-scale trial in diverse LMIC context. And the practice implications are enhanced accessibility, that is multi-platform delivery, offline option, low literacy usability, and use the user-centered and culturally adapted design. Improve engagement reminders, peer forms, husband involvement, and the digital tool should extend, not replace traditional care. And the policy priorities are that is invest in broadband expansion and digital literacy programs, and ensure reimbursement parity and privacy and security standards to build trust, and fund community-based and translated implementations, and digital postpartum depression tools into national maternal health guidelines. And in conclusion, digital interventions reduce, hold to promise reduce postpartum depression and extend care, but to do effectively, we can invest infrastructure, culturally adapted design, and a strong evidence in LMICs. These are the reference, and thank you. Thank you for your support and cooperation. I welcome your suggestions and feedback.
Okay, thank you. Ma'am, you can proceed with the questions.
Yeah. Just explain me what exactly you want to say by considering digital health.
A digital intervention can help reduce postpartum depression. In LMICs, limited internet access reduce their impact. Simple, low-tech solutions are needed.
And what are the factors you have considered in postpartum depression?
Digital programs used reduce to postpartum depressions, and we used some some articles, and we can find out that digital intervention can reduce postpartum depression due to the evidence base.
So, what are the ways you have selected in digital health?
Sorry, ma'am.
What are the important parameters you have selected in digital health in postpartum depression?
Because
And why you have chosen those parameters into the digital health?
sorry, ma'am, I can't
Did
hear.
you get
Your voice is breaking.
in the digital health? You are considering digital health in postpartum depression. Am I audible?
Yes, yes, ma'am.
So, what are the parameters and why you have chosen them into the digital health?
And that is physical recovery, with a vital signs, vaginal bleeding, uterine fundal height, wounds, healing, pain levels, and mental emotions, well-being, lifestyle, care coordinations. These are the parameters.
And how
Why
you
these
want to digitally help to the person who is suffering from the postpartum depression?
ac- that is accessibility, usability, data security, and focus. And digital health aims to provide continuous support, address critical information needs like breastfeeding or baby development, and monitor conditions that suffers in the first year postpartum, reducing maternal mortality and mortality.
Okay, fine.
Ma'am, can you please ensure your presentation? So for the next presentation, I would like to call Tejas for the paper title, Explainable Deep Learning Models for Oral Cancer Detection and Performance Evaluation. I kindly request the presenter to start with the presentation.
My screen is visible?
Yeah, it's visible.
Okay. So good afternoon, everyone. My name is Tejas Dendi. Today will be presenting our work on explainable deep learning model for oral cancer detection and performance evaluation. So first is the introduction. In the oral cancer is the major global health issue, and there are often detected very late because of the early screening and tools are limited. Then deep learning model can automatically analyze the oral cancer and detect the cancerous regions. Then, however, most models can works like black box. We can get the predictions, but we don't know we don't know why the model can make these decisions. So we can work on the integrated with the explainable AI, and for the in the explainable AI, focusing on only there are two main techniques. That is, first is the grad CAM, and next one is the lime. And then it using of the explainable AI model can improve their transparency and clinical trust and diagnostic confidence. Next is a problem statement. The traditional diagnosis is the experts depends on the subjective, which can the causes deals and the variability. And deep learning can use the high accuracy, but doctor doctor don't trust on the black box system without any explanation. Then the lack of the transparency limited in the real words and use the AI in healthcare. So our problem is we can make the deep learning model to both accurate and the explainable for oral cancer detection. Next one is the objective. Objective is to develop the conventional neural CNN based model for the automatic detection of the oral cancer from the clinical non-tissue image. Then to addresses the black box limitation to deep learning model by the integrating the explainable and artificial using of the explainable artificial intelligence techniques to apply the grad CMA and lime to generating the global and the local visual explanations of the model predictions. And next last objective is the to provides the clinically interpretable and insights that the enhance the trust, transparency, and the decision making in the oral cancer detection. Next one is data set. Data set is the we are used to combine the from three data set from Kaggle sources. First is the histopathically pathological oral cancer dataset. It is the binary dataset. Second one is the oral cancer lips and tongues datasets, and last one is the oral cancer types and region. It is the multi-class dataset. There are contains the total 972 images. Is the cancerous images are 482, and the non-cancer is the 490, and includes the tissue and non-tissue oral cancer images. There are includes the lips, tongues, and the oral cavity regions. And we are pre-processing image resize in the two standard size, that is the 224 into 224, and normalize, and the augmentation like the rotation and flips to data was split into the 80% trained and 20% validation. Next part is the methodology. This is the methodology diagram. First is the data collection and pre-processing. In the data collection and pre-processing, we are pre-processed on oral cancer images first, and the image resize, normalize, and apply the augmentations to we can enhance the quality and get the high accuracy using to improve the accuracy, and it is easy to increase the accuracy to model. Then use the transfer learning. For the transfer learning, we are using pre-trained CNN model, that is efficiency net B3 model, and the custom dense layer we are added is the oral cancer classification. After the transfer learning, next is the model training and evaluation. In the model training and evaluation, we are trained the model and validate using the accuracy with the loss matrix, and then apply the explainable AI technique. First we apply the grad CAM to highlight the important reason why in that the influence part, and then apply the lime. Lime is provides the local pixel based on the explanation for the individual image predictions. And after the explainable AI, that are we applied the grad CMA and lime then to explain the model predictions visually. Next one is the model performance. In this slide, where shows the training stability and performance. The model can overall get the accuracy is 82.93%, and here we have see one the graph, that is the total number of epochs, and uh, how the model can increase their accuracy with the increase in number of epochs. In the loss curve can indicates the good. Here we see loss curve. Loss curve can indicate the good convergence without any overfitting, and there are the and this confirms the model can learns in the meaningful features from the oral images. Next is the grad CMA implementation and the output. Grad CMA technique is the explainable AI technique that we are used. The grad CMA is the means gradient weight class activation mapping function. It is the visualize the technique we are that used for gradient flow into the final convolutional layer to create the heat map. Uh, it it uses the gradient from the convolutional layer and generates the heat map. This heat map can shows the where model and looking when the predicting the cancer. The implementation steps of grad CMA. First is get the images, then apply the gradient calculation. In the gradient calculation, we are compute the gradient and the predict the class score with the respect of the last convolutional layer. And then the weight averaging. In the weight averaging technique, we are average the gradients to obtain the improve the weight of the each feature map, and then it generates the heat map. In, in this, multiply the weights in the features map and apply the ReLU to generate the grad CMA heat map, and then visualize that cancerous part. Here we are see first this is the original image, and we are enhance the quality using of the grayscale, and the model here model R shows the cancerous part showing the heat map. And in the last section D, we are show the confidence level, what percent of confidence level means how much part are cancerous. There shows 82%, and here gives the explanation of the model why these parts are cancerous. The explanation is given by the AI. Here we are optimized for the better input. Here we are grad CMA we are optimize the image to optimizing the input better explainability to pre-processing on image using of the grayscale. So enhance the
Sorry for the interruption, but you only have 1 minute to complete the presentation.
okay. Okay. Next part is the lime. Lime can explain the prediction is locally by the dividing into image superpixels, and it can produce the regions. We can check the how the prediction can changes, and in the limes can image divide in the superpixels, and there are the highlights the important regions. Here is the shows the output of the lime. Next, we are using here one mini LLM part that is the explains the how's the why the that parts is highlighted and why the model shows the cancerous part that is explained by the mini LLM. Next is the comparison between the grad CAM and lime. Grad CMA is the model specific and the lime is the model agnostic is basic, and then grad CMA is the explanation scope is the global and highlight the important regions and then entire predictions, and the lime can explains only the predicted and the small regions. grad CMA is highlight grad CMA is the output shows the heat map, and lime can divide the image in the superpixels and showing the positive and negative influence. Then lime GradSim is working fast and efficient. Lime are slower and multiple perceptions. Last one is the next slide is conclusion. We can develop the on explainable AI deep learning framework for the oral cancer detections, and the model can achieve the reliable performance and maintaining the explainable explanation. And then GradCMN and Lime can successfully addresses the black box problem. This approach can improve the clinical trust and supports the real world screening and applications. The future works is the in the future we can plan to use the larger and multi-class data sets, and next is the integrate with the his, histo uh, histopathologically and the multi-model data and apply the advance the architecture with the clinical validation and the real deployment. This is the references. Thank you. Thank you for your attention.
Thank you, Tejas. Ma'am, you can proceed with your questions.
Okay. Why you have like chosen the explainable AI in solving this problem, which can be easily solved by using CNN algorithms?
Because ma'am, the deep learning model can gives the direct output, but it is shows the black box. Means normal peoples or doctors can't understand why the model can shows their output and why these parts means for example model can shows the one part of the oral cancer and shows it gives the answer is the cancer, but people are don't know why. The explainable AI can pre-process on it, and it gives the answer why the regions are oral cancer and why the oral cancer model can uh, gives the answer. Hello.
Just let me know how like clinicians will trust your system in early diagnosis of the oral cancer.
Uh,
Did you get my question?
uh,
How your model is giving the confidence to the clinicians to trust on your model in oral cancer detection? Have you done the testing onto the real world samples or apart from your training data set?
no, ma'am. I am applied in on the different Kaggle images and the we have, online images that oral cancer images. I am applied on it also. So model gives the correct explanation why these people person having the oral cancer, and model why shows the model this the why shows the model the result is the cancer.
Have you tested the explanations given by your explainable AI with the clinicians?
Uh, uh, Please repeat the question, ma'am.
Have you verified the explanations
Yes, ma'am.
given by your model with clinicians?
Yes, ma'am.
Have you tested your model?
Yeah, yes, ma'am. I'm tested on my model, and I'm
Uh,
working with means I am test means what to say. I'm also clinically tested on with doctors, and it gives the correct answers.
where
And the model.
exactly you find the difficulty in deploying the results?
Mm,
Done from my side.
Team. So thank you, Tejas. Can you please ensure your presentation? So for the next presentation, I would like to call Prakash Mishra for the paper title, Formal Verification of Software Managed Cache Coherency for Risk-Free Heterogeneous Embedded System. I kindly request the presenter to start with the presentation.
Okay. Yeah, can you hear me and see my screen?
Yes, it's visible.
I'm just asking again. Can you see my screen and hear me?
Yes.
Thank you very much. Okay. Good afternoon, everyone. My name is Jyoti Prakash Mishra, and today I will be presenting our work on the formal verification of software managed cache coherency for RISC-V heterogeneous embedded systems. This work addresses a correctness and performance problem that arises in modern embedded platforms that use non-coherent DMA, particularly in systems adopting the RISC-V JIC-BOM cache management extension. I will walk you through the motivation, the formal model, the main theoretical results, and the practical impact of our approach. Modern embedded systems increasingly combine CPUs with accelerators, sensors, and peripherals. These components exchange data through shared main memory, often using DMA, which is direct memory access, for high throughput transfers without continuous CPU involvement. In many cost-sensitive systems, DMA engines are non-coherent. They bypass the CPU caches entirely and directly access main memory. This reduces hardware complexity but introduces subtle correctness risks when write-back caches are used. Dirty cache lines may not be visible to DMA, and DMA writes may overwrite memory while CPUs continue to use stale cached data. Without careful management, this leads to silent data corruption. RISC-V addresses non-coherent DMA through the JIC-BOM extension, which provides explicit cache management operations. These include clean, invalidate, and flush operations that software must insert explicitly. The key observation is that normal CPU instructions and cache management operations preserve coherency and when there is no DMA, but only DMA activity can introduce incoherent states. In practice, developers often conservatively insert a flush before every DMA operation. This guarantees correctness but incurs a high performance cost and lacks any formal justification. This gap motivates the need for precise rules and formal verification. The root cause of the problem is that DMA accesses memory while bypassing CPU caches. As a result, cache state and memory state can temporarily diverge. This leads to two main classes of errors. First, stale reads, where DMA reads outdated memory while the CPU holds newer data in its cache. Second, lost writes, where DMA overwrites memory while the CPU caches the same address. These violations are silent and extremely difficult to debug. Correctness therefore depends on where DMA accesses occur, which cache lines overlap, and where cache management operations are placed. The conservative approach of flushing before every DMA is correct but inefficient. Flush operations are expensive because they combine write back and invalidation. This overhead is significant in real-time audio pipelines, sensor fusion workloads, and accelerator offload paths. Despite this cost, there is no formal semantics for JIT bomb and no decidable verification framework. As a result, optimization is risky and correctness relies on informal reasoning. Our core challenge is to guarantee DMA coherency formally while eliminating redundant cache management operations. We model a heterogeneous embedded system with processors, DMA engines, a shared address space, and a value domain. Each processor has a private write-back L1 cache. Main memory is shared. DMA engines bypass all CPU caches. Caches are modeled at cache line granularity. Each processor and address pair has an independent cache state. DMA operations never modify cache state. We assume a single cache level and sequential consistency to focus precisely on software-managed coherence. Each cache line is modeled with a three-state abstraction that is invalid, clean, or dirty. Invalid means no cached copy exists. Clean means the cached value matches the contents of memory. Dirty means the cache contains a newer value than memory. The global system state consists of all cache states and the memory state. The key separation is that caches are visible to CPUs while memory is visible to DMA. Coherency violations arise exactly when cache and memory disagree due to DMA bypassing caches. We define formal semantics for CPU operations, cache management operations, and DMA operations. CPU loads and stores behave as expected under a write-back cache. Cache management operations clean, invalidate, or flush cache lines. DMA reads and writes access a memory directly and never affects cache state. The critical point is that CPU and cache management operations preserve coherency invariants. DMA operations are the only source of incoherency when preconditions are violated. We define coherency per address. At most, one cache may hold dirty data for an address, and all clean cache lines must agree with memory. The current value of an address is defined as the dirty cache value if one exists, otherwise the memory value. A coherency violation occurs when an observer, either a CPU load miss or a DMA read, observes a value different from the current value. This definition allows us to precisely characterize when DMA operations are safe. We prove two key theorems. First, a DMA write preserves coherency if and only if all caches for that address are invalid. Any cached copy would either lose CPU rights or violate clean memory management agreement. Second, a DMA read returns the correct value if and only if no cache holds dirty data for that address. From these results, we derive minimal cache management requirements. Before a DMA write, invalidate is sufficient. Before a DMA read, clean is sufficient. Flush is never minimal. We encode coherency checking as a deterministic finite automaton. Each state represents a cache configuration. Transitions correspond to CPU, cache management, and DMA operations. Error states are reached exactly when a DMA operation executes without satisfying the safety preconditions. A program trace is coherent if and only if it is accepted by this state machine. This gives us a precise and executable correctness criterion. For finite program traces, coherency verification is decidable. The state space grows exponentially with the number of processors and addresses, but verification is linear in the length of the trace. For unbounded programs, precise verification becomes undecidable. This motivates conservative but sound static analysis for optimization. Using our formal results, we design a data flow-based algorithm to eliminate redundant cache management operations. A cache operation is redundant if removing it does not affect coherency. We use a forward analysis to track abstract cache states and a backward analysis to track which DMA operations may reach each program point. Based on these analyses, we safely remove unnecessary clean, invalidate, and flush operations. We implemented our model and optimizer in Python and evaluated it on 6 embedded benchmarks across workloads such as DMA transfer, producer-consumer pipelines, accelerator offload, and sensor fusion. We achieved an average reduction of 58.8% in cache management operations. All optimized programs were formally verified to be coherent. Estimated cycle savings averaged 26.6%. To summarize, this work presents the first formal automata-based model for software-managed cache coherency in RISC-V systems with non-coherent DMA. We provide necessary and sufficient DMA safety conditions, decidable verification for bounded programs, and a sound optimization algorithm. The practical result is significant performance improvement with formal correctness guarantees. Thank you for your attention. I'll be happy to take questions.
Okay, thank you, sir. Ma'am, you can proceed with your questions.
Hello. Hello, am I audible?
Yes, you're audible.
Okay.
Okay, so ma'am, I have no questions. So now let's move on towards the next presentation. So for the next presentation, I would like to call Amal Krishnan for the paper title, Inclusive Classrooms and Emerging Assistive Tech, a Framework for DHH Learning. I kindly request the presenter to start with the presentation.
Am I audible?
Yes, you're audible.
Okay, ma'am. Thank you. Let me share my screen. Is my screen visible?
Yes, it's visible.
Okay, thank you, ma'am. Good afternoon, everyone. I'm Amal Krishnan, working as a project coordinator in Amrita Create, as well as a PhD, part-time PhD scholar in Amrita School of Business, Amrita Vishwavidyapeetham. Today, I'll be presenting a conceptual framework for creating an inclusive classroom for deaf and hard of hearing learners. So this is not an empirical study, but what I'm trying to do is to show you about a design science artifact that I'm proposing as a three-dimensional framework, which means technology, pedagogy, and policy that integrates three learning foundations that I've considered for this work that are UDL, Universal Design for Learning, then socio-cultural learning theory, and bilingual, bicultural model of deaf education. Starting with the statistics. As per WHO data, there are around 13 billion people across the world who are suffering from hearing impairment in various degrees. And when it comes to the national data in India, as per the statistics, there are 63 million people who suffer from deaf and hard of hearing, which means the DHS population stands at the second position when you consider the percentage of disability across the nation. And if you look at the children population who are at the educable age group below 19 years, deaf and hard of hearing children are around 15.7 lakhs, which means that also constitutes to close to 20 percentage of the population. Coming to the problem and context, Inclusive education is a global priority, as we know, under SDG 4 and SDG 10, quality education and reduced inequalities. But still, DHS learners continue to face persistent barriers in mainstream classrooms. And these barriers are not just technical, but also systemic and social. Most participation are still mediated and not direct, which means they will need interpretation support as well as caption or any other special arrangements. And during the period of COVID-19, these problems became more visible. Like digital learning has exposed huge access gaps, especially for DHS students. And despite the good intentions, this current inclusion practices are still remaining as fragmented. So what we need is a systemic technology enabled and culturally responsive approach and not just isolated fixes. The current solutions and gaps, we do have solutions, but as I just mentioned, all are fragmented and each of them comes with certain limitations. For example, interpreters provide natural language access, but they are scarce and costly and also difficult to scale across the nation. And captioning gives real-time access, but accuracy, latency, and lack of interactivity remains an issue in that aspect also. And hearing aids and FM system, frequency modulation, they definitely improve audibility, but are still individualized and prone to interference. And there are many specialized apps also, which are useful, but they are siloed and poorly integrated into a pedagogical environment. So across all these tools, we see common gaps like reliability, teacher training, social stigma, and scalability. Coming to the theoretical foundations, as I mentioned, UDL, socio-cultural and bilingual, bicultural. The framework is grounded in these three complementary theories. UDL emphasizes multiple ways of representing content, engaging learners, and expressing understanding. So this aligns naturally with a multimodal access for DHS learners. And the second, sociocultural learning theory, it reminds us that learning happens through tools and social interaction. So technology must support collaboration and not isolate students. And third is the bicultural and bilingual model, which centers sign language and deaf culture. So the technology should support sign competence rather than replacing it. So together, these theories ensure that technology, pedagogy, and culture work together and not in conflict. The proposed framework, based on these foundations, I propose a roadmap from theory to practice. It starts with conceptual design, integrating assistive technology with inclusive pedagogy, then moving to pilot testing in real classrooms, then followed by an evaluation using academic, social, and institutional metrics. So finally, the framework extends to a policy and scalability, including sign language curricula and educator training as well. So this positions this framework as a design science artifact, basically blueprint for future implementation and not just a theoretical idea. Coming to the components framework of the framework, first one is like core architecture of this proposed framework, and this is where the idea of integration becomes critical. So most current assistive technologies for DSS learners functions as standalone add-ons, and here in this framework, this is like designed as an unified ecosystem with three like layers, different layers, which I'll just explain. First one is educator support tools, where inclusion must begins with how teaching is delivered. So teacher speech is automatically converted to a real-time text displayed on adaptive digital screens that synchronize with classroom discourse. And this is not just caption, it is pedagogically integrated transcription aligned with UDL. And then there is Oracast broadcasting, which is a pretty new technology which will come into the market in next 4 5 years, which is going to replace this FM frequency modulation systems for this deaf and hard of hearing population. And this means the same teaching moment is accessible to all students simultaneously without any segregation. And adaptive displays allows teachers to present multimodal content with a combination of visuals, text diagrams, live transcriptions, etc. And then the second layer, learner support tools, to focus on student participation. The students, DHS students, can contribute through text-based input, sign language video, or collaborative documents, enabling them to respond in modality. which is more natural to them. And this directly supports this social cultural learning, because learning is not just receiving information, but should be in collaboration with the interaction, dialogue, and meaning making. And then the third layer is accessibility customization, which is very important for the personalization and equity. Each learner has a customizable profile that controls text speed, font size, contrast, language, and display preferences. And this multilingual and sign language support ensures this bilingual, bicultural identity as sustained and not overridden. So the key idea here is technology, pedagogy, and accessibility are not separate layers. They're like tightly coupled into a system. Uh, Coming to the classroom application, a hypothetical scenario, just imagining a mainstream
Sorry for the
classroom.
interruption, but you only have 1 minute to complete the presentation.
Sure, ma'am. I will make it fast. Uh, so this is just the mainstream classroom scenario. With the teacher interaction, as teacher speaks, their voice is automatically captured and processed into parallel ways, like real-time captions and oracast. And then student participation. When ADHS students wants to respond, they are not dependent on an interpreter. They can type their response, use sign language through a video channel, and also collaborate in shared documents. So this transforms participation from a passive accommodation to an active engagement. Personalization and privacy. Each student's accessibility profile automatically adjusts how information is presented and why this matters. So what we see here is not just a classroom with technology. We see a classroom where communication barriers are removed at the system level. And comparative analysis. I'm just going a little bit fast now. Existing solutions versus this current framework. So this table shows how the framework improves on existing solutions. Captioning becomes interactive and personalized. Interpreters are supported through embedded bilingual curricula. FM systems are replaced with scalable oracast broadcasting. And then specialist apps become part of a unified ecosystem, as mentioned earlier. The conclusion and future directions. To conclude, this framework represents a shift from accommodations to an integrated ecosystem for DHS inclusion. So this benefits span academic engagement, social integration, and institutional capacity building as well. So from a policy perspective, we need to mandate sign language curricula, fund inclusive infrastructure, and also train educators at scale. And all this will be in ensuring equity, affordability, and privacy by design. So then next steps include pilot testing, longitudinal evaluation, and adaptation across contexts. So ultimately, like inclusive education is not about adding support, but about redesigning classrooms so everyone belongs by default. So these are few of the references that I have used, and thank you so much. So
Okay,
open to
thank
any
you.
suggestions and questions, ma'am. Yeah.
Ma'am, you can proceed with the questions.
Okay. What inclusive design principles form the foundation of your proposed framework for DHH learners?
Yeah, basically, I've considered three, ma'am. One is the universal design for learning, and then socio-cultural learning theory, and then bilingual bicultural model, which is specifically for deaf education. Because sign language is to be considered not just as a language, but as a culture itself. So these are the three learning foundations that I considered here, ma'am.
Why you choose these assistive technologies to integrate into the DHH learner specific system?
Ma'am, because see, the way the technology is advancing nowadays, assistive technology plays a great role in making their life easier, right? So why shouldn't we look for an integration where this assistive technology can enhance the learning environment for these DHS learners so that the classroom becomes inclusive for them as well? So that is a motive and a novelty for me to consider this work, ma'am.
According to you, what are the challenges in implementing this framework in mainstream education system?
First one is definitely scalability, ma'am. We do need startups and initiatives that come forward with new innovations that can be scaled across the nations. And well, speaking of that, policy, the effective implementation of the existing policies also play an very important role in that.
Okay, done from my side.
Thank you so much, ma'am.
Okay, thank you, Amal. Can you please unshare your presentation? So for the next presentation, I would like to call Sonali for the paper title Intrusion Detection in Heterogeneous Wireless Sensor Network, a comprehensive review. I kindly request the presenter to start with the presentation.
Am I audible and my screen is visible?
Yes, it's visible.
Okay. So myself Sonali Bhote. Today I will be presenting my research work with the title Intrusion Detection in Heterogeneous Wireless Sensor Network, a comprehensive review. This work focus on security challenges in a heterogeneous wireless sensor network, particularly the black hole attacks, the highlight advanced AI-based detection technique. So this is the outline of my presentation. So we'll start with the introduction. So wireless sensor network typically consists of a large number of low power sensor nodes. These nodes are suffer from several constraints like limited memory, low computational ability, non-rechargeable batteries. So energy is the most precious resource. Conserving energy, extending a network lifetime is a major challenge in WSN design. So introducing the heterogeneity among the sensor nodes will help to improving the reliability, reducing the latency and prolonging the network lifetime, but it also introduces new security challenges. This is the typical WSN architecture where the sensor node collects data and forward it to the base station either directly or through the multi-hop routing. Such open and distributed communication makes WSN vulnerable to the various attacks. So this is the overview of WSN, where WSN faces the several security issues such as authentication failures, data integrity, confidentiality violations, and the denial of service attacks. So one of the major serve of the routing attack is the black hole attack, where the malicious node advertises itself as a having the shortest route to the destination, and once the traffic is routed through it, the malicious node drop the packets intentionally, causing the severe packet loss and the network disruption is there. So the intrusion detection and anomaly detection systems are essential to identify and isolate the such malicious node. So the need of research is that due to the severe impact of black hole attack, the network performance, reliability, security are deeply compromised. To have the accurate and reliable attack detection can significantly improve the network security and extend the network lifetime. The motivation for this is the black hole attack. In this, in the block data transmission and the major inject malicious program into the sensor node. So they exploit the trustworthiness of the routing protocol and causes the high end-to-end delay and the low throughput. So although many detection techniques are exist, most of them are suffer from the high false positive and the poor adaptability. So the problem definition of this is the attack and the intrusion are the frequent in WSN. So because of their open and the resource constrained nature, the malicious attack attracts the traffic by advertising potential optimal routes and then drop the packets and leading to the loss of the critical information. So the key challenge is to improve the network security without compromising the energy efficiency and the network lifetime. So this is the literature survey. So the traditional uh, the existing intrusion detection system is proposed for the wireless heterogeneous wireless sensor network. So the traditional rule-based, signature-based IDS approaches having the lack adaptability, while machine learning based systems are often suffer with the high-level false alarm. Recent deep learning methods were there. They're also going to have some compromises over there. So this is the comparative overview. This comparative overview analysis shows the existing methods are going to have the trade-off between the detection accuracy, energy consumption, and the network overhead. Uh, Based on this, again having some literature survey I have done based on the black hole attack detection protocols. First is the comparative overview. So this is going to represent the comparative overview for the various black hole attack detection approaches are going to get proposed in this survey. This is the this is the traditional one. So here the traditional black hole attack approaches mainly rely on the rule based, signature based, and the cryptographic one. Then having the trust-based detection approaches were there that is going to have assigned with the trust values to the sensor nodes based upon their behavior, such as the packet forwarding and cooperation. Next is the machine learning approaches were there. They are there to overcome the limitations of traditional methods. Machine learning based approaches have been introduced. Then the deep learning based approaches were there. So recent research is going to get explored to the deep learning models for the intrusion detection in wireless sensor network. So the deep learning techniques automatically learn the complex pattern from the network traffic data and outperform the traditional machine learning models. So this is the comparative overview, which is going to have the combination of traditional plus the trust-based method, which is suffer from the limited adaptability and high overhead, machine learning techniques that improve the accuracy but depends heavily on a feature selection and the static model. Deep learning approaches, which is going to offer the better performance, but still they are going to face the challenges related to the optimization and energy efficiency. And this comparative analysis clearly highlights the need of more robust and optimized intrusion detection system. So this is the research gap. After having the extensive research literature survey, I have identified the critical research gap. Like most of the intrusion detection systems for the WSN is focused on improving the network architecture or the detecting the models. However, it largely ignores the loss function optimization, which directly affect the learning stability, convergence speed, and the detection accuracy. So this is the methodology overview. So methodology consists of the multiple phases starting from WSN stimulation to the simulation to the final attack detection. The network is first stimulated with the heterogeneous sensor nodes and energy, mobility, and the link lifetime model is going to get incorporated. Then the clustering, routing, and the attack detection phases are going to be executed sequentially to ensure both the security and the energy efficiency. So these are the simulation parameters that I have used that with the help of this, the heterogeneity is going to be help to improve the network lifetime reliability, but also introduces the routing and the security challenges. So these are the energy model is going to be get developed to estimate the energy consumption during the transition and the reception. So mobility model is going to have an account for the node movement with the impactors on routing paths. So the link lifetime model is going to predict the stability of the communication link. This is the highlight of the framework. First, to propose the end-to-end secure wireless network development, then introduce a novel tire-based hybrid loss function, and to have the achieve the black hole attack things. Next one is the proposed system architecture. I'm going to explain these things. Next is the experimental setup. So for experimental setup, these are the fitness functions are going to be get used. This is the step-by-step things like the cluster formation, cluster head selection, multi-hop routing, log collection, address station, feature selection, and the black hole attack detection. These are the experimental setup and are going to be get used. It is going to have the cluster formation as a first step. Then the secure multi-hop routing is the second phase. Third is the log collection at base station and the high dimensional data challenge is there. So for this, the lasso or the least absolute shrinkage selection operator is going to be used for the feature selection. It eliminates the irrelevant features by forcing their coefficient to the zero. This will reduce the overfitting, speed up the training, and improve the detection accuracy by retaining only the most relevant features. Along with that, the selected features are going to be include the packet and the receive count, packet drop rates, and the node identifies distance and the cluster heads to the base stations and timestamp and the routing paths. Then the deep stack encoder is there. After feature selection, the reduced feature set is going to get fed up to the deep stack autoencoders. Autoencoders are the neural networks that learn to construct into the input by stacking multiple encoders. Hierarchical and the abstract presentation of network behavior is going to be get learned. So DSA consists of the multiple encoder decoder layers are with them. So this is the experimental setup for it. This is the deep stack general architecture is there. So how this particular thing is going to be used, it is going to be learn the normal routing behavior, malicious attack hole patterns, and it is going to give out it is going to give a final layer classifies the normal nodes and the black hole nodes. These are the advantages of deep stack autoencoders. Now there are the limitations of traditional loss function, like they are going to be get unstable training and the bias prediction is there. So they may going to have the converge slowly and produce the high false negative, which is going to have the dangerous in the intrusion detection system. So for that, the TBL loss function is there. So it is going to be get mainly proposed the core novelty to this work, which combines the Bickel loss for the smooth convergence with the mean bias error to reduce the prediction bias. So the Taylor series is going to have the expansion is applied to stability gradients and the balance both the loss components. Why this Taylor series are going to be used? Because it approximate the smoothness sudden gradient changes that is going to happen during the training. This is going to lead to have the stable weight
Sorry
update.
for the interruption, but you only
Yes,
have
yes,
1 minute
we'll
left to
conclude
talk.
it. Yes.
Okay.
So the faster convergence and improve the learning behavior. So as the result of this, the detection in accuracy and recall is significantly enhanced. So these are the results that I am going to have. So the train the DSF with the proposed Taylor-based Bickel mean bias loss to define the normal and the black hole nodes. Detection is going to be performed with the base station and minimizing the energy usage at the sensor nodes, and malicious nodes are going to be identified and isolated from the routing path. So these are the results that I have achieved. So the experimental setup, for experimental setup, I am using with the WS and DS dataset is going to be used. MATLAB is used for the simulation with the 100 nodes, 80 training echoes, and the Adam optimizer is used. K-fold cross validation is going to be applied to ensure the robustness and the reliability of the results. So this is the performance matrix. So the performance is going to be evaluated using the accuracy, precision, recall, and F1 and the detection rate. These matrices are going to provide the comprehensive assessment to the intrusion detection things. So, uh, so I'm going to conclude these things. This work is going to represent the secure and energy efficient intrusion detection framework for heterogeneous WSN. The combination of optimized routing with the lasso based feature selection, deep stack autoencoders, and the novel Taylor bias mean loss function significantly improves the black hole attack detection, which this approach is going to improve the network security while prolonging the network lifetime. So thank you. Any questions?
Thank you. Ma'am, you can proceed with your questions.
Yeah. Uh, what are the major research gaps or open challenges does the review identify?
First one is the network lifetime issues are there. Battery issues were there. To handle these things and to identify the attack detection at the base station is the major challenges that I have faced across the literature survey. So these are the key components that I have taken into the consideration for this research work.
Okay. What future research direction does your review recommend for intrusion detection in heterogeneous wireless sensor network?
Actually, the proposed system is going to be get executed with the trial based Bickel means bias loss function that I have used. Here I am getting the few parameters associated with the accuracy not getting better results as compared to the existing algorithm. So I am trying to tune these things with the deep learning approach in future.
And what criteria were used to select and categorize the studies included in this review?
Mainly, I have distinguished the things with the what are the different traditional approaches were there for the attack detection. Then, based on the different sets, like different traditional approaches that mainly rule based, signature based, or the cryptographic techniques were there. On that, I have distinguished things. And then I'm again distinguished based upon the trust based and the routing based approaches, then the machine learning based approaches and the deep learning based approaches. So I have done the survey based on these different approaches.
Okay, done from my side.
Okay. So now let's move on towards our last presentation. For this, I would like to call Jyoti Prakash Mishra for the paper title RV Josh, a hardened operating system for risk-free based on Java. I kindly request the presenter to start with the presentation.
Okay, can you see the screen and hear me?
Yes.
Okay, thank you. So I'm back again. Good afternoon. My name is Jyoti Prakash. I just gave a presentation a few minutes ago. And at this time, I'll be presenting RV-JOS, which is a hardened operating system for RISC-V based on Java. This work explores how language-level safety combined with operating system-level security mechanisms can address emerging threats in open instruction set architectures. In this talk, I'll briefly motivate the problem, explain why we chose a Java-based operating system, walk through the system architecture and security mechanisms, and conclude with evaluation results and key takeaways. RISC-V is seeing rapid adoption in both academia and industry because of its open instruction set, extensibility, and reduced licensing costs. Projections suggest that RISC-V could account for nearly a quarter of the global processor market by 2030. However, this openness also increases the attack surface. Systems are becoming more exposed to malware, memory corruption, and side channel attacks. At the same time, there is a lack of mature, security-first operating systems specifically designed for RISC-V. A key observation from our work is that security cannot rely only on hardware defenses. It must be addressed at the OS level, where policies and protections can evolve more rapidly. Most conventional operating systems are written in C and assembly. While these languages offer low-level control, they provide very limited safety guarantees and are prone to memory corruption and type-related vulnerabilities. Modern kernels also consists of millions of lines of tightly coupled code. This makes them difficult to maintain and even harder to extend with new security mechanisms. In fact, RISC-V related contributions to the Linux kernel have been rejected by the founder, by the creator, Linus Torvalds, in the past due to maintainability and code quality concerns. This leads to our problem statement. How can we design a secure and malware-resistant OS for RISC-V that reduces low-level complexity, enables rapid security innovation, and remains practical even for constrained environments such as IoT devices? Java provides several language-level guarantees that eliminate entire classes of vulnerabilities common in C-based kernels. These include automatic memory management, strong type safety, array bounds checking, to name a few. By using Java at the OS level, we significantly reduce the kernel attack surface and lower the barrier for researchers and developers to contribute new ideas. This encourages faster experimentation with security mechanisms. Earlier Java operating systems such as JNode and JX demonstrated feasibility, but they are no longer actively developed, do not target RISC-V, and lack integrated malware detection and memory encryption. RV-JOS is designed to fill this gap. RV-JOS follows a layered architecture that cleanly separates hardware-specific logic from security-sensitive services. The boot process and early initialization are handled in assembly, including multi-hearth setup and trap configuration. Core kernel functionality such as memory management, scheduling, system calls, and drivers is implemented in C. Higher level services, including the JVM, secure class loading, malware detection, and cryptographic services are implemented in Java. This separation ensures that low-level hardware control remains minimal, while policy and security logic benefit from Java's safety and extensibility. Static malware detection in RV-JOS occurs at process creation time, before any Java program is allowed to execute. The input is the raw Java bytecode extracted during class loading. We extract opcode level features, specifically 1 gram and 2 gram opcode frequencies. These features capture structural patterns commonly associated with malicious code. Classification is performed using an ensemble approach that combines a random forest classifier and a feed-forward neural network. If a class is identified as malicious, it is rejected before reaching runtime, thus significantly reducing system exposure. Static analysis alone is not sufficient, especially against polymorphic or behavior-based malware. To address this, RVJAWS includes dynamic malware detection that monitors runtime execution behavior. We extend QEMU using its official plugin interface to collect fine-grained execution data, including instruction mix, branch density, memory access patterns, system call frequency, and self-modifying code behavior. These features are analyzed using multiple models, including sequence-based models, temporal models, and outlier detection. This layered approach allows the system to detect threats that evade static analysis. RVJOS includes a page-level memory encryption mechanism designed to protect sensitive data in RAM against physical attacks and side-channel attacks such as simple and differential power analysis. The system extends QEMU with a transparent encrypted page cache. Guest memory stores only encrypted pages, while decrypted pages exist only inside the CPU emulation context. Plain text never appears in guest RAM. The design supports multiple software-based encryption algorithms and uses hardware-derived keys from a modeled physical and clonable function. Constant time operations and periodic rekeying further strengthen resistance to side channel attacks. We evaluated RVJOS on a QEMU-based RISC-V platform using a bare metal toolchain. Kernel boot time ranges from 22 to 38 milliseconds, with JVM initialization and cryptographic setup contributing the most overhead. Memory encryption performance shows that CHA-20 achieves the highest throughput in software, followed by ASCON, with AES being the slowest without hardware acceleration. This highlights the trade-off between security and performance. Malware detection and inference latency remains within practical limits for both static and dynamic models, enabling real-time enforcement without significant slowdown. In conclusion, RVJOS demonstrates that a Java-level operating system for RISC-V is not only feasible, but also advantageous for security-focused design. Language-based safety significantly reduces the kernel attack surface, while integrated malware detection and memory encryption provide multi-layered protection. The system currently relies on synthetic malware datasets and QEMU-based evaluation. Future work includes testing with real-world malware and exploring hardware-assisted security extensions. Thank you for your attention. I'll wait for questions now.
Thank you. Ma'am, you can proceed with the questions. Okay, so ma'am, I have no question. Now let's move toward the closing remark. You can kindly unshare your presentation. So I sincerely thank our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of whole team, thank you for support during this 10th version and all the previous 9 version of conference. We will be happy to have you in the 11th conference, that in 2027. All the presenter will be getting their digital certificate through mail within 2 working days. The publication will be live within 7 to 8 months. Kindly cooperate with the team of SMARTCOM 2026. I also thank our session chair, Professor Nisha Abhijit Avati, for chairing the session, a token of appreciation to the chair on behalf of Team SMARTCOM and Global Knowledge Research Foundation and partner. Thank you, ma'am, for your valuable presence. Now I kindly request everyone to switch on their camera for a quick snapshot. Okay, thank you everyone. You all can leave now.